Alright, this is the first lecture for Unit 4. Unit 4 is an introductory segment on solutions and concentration. Specifically, we'll address the sort of calculations you'll make in future laboratory courses. Technically, a solution is any homogeneous mixture, which we introduced back in Unit 2. Alright, so there are at least two parts. The solvent is what there's the most of. The solute is whatever there's less of. And in lab, you will mostly be interested in aqueous solutions. Aqueous solutions are ones where the solvent is water. So, for example, a typical saltwater solution, the solvent is water and the solute is salt. Concentration is about how much solute there is for a given amount of solution. And chemists are interested in molarity, which is moles of solute per liter of solution. If you're aware of the definition of molarity, you can attempt this problem. 50.8 milligrams of KMnO4, the name of this is potassium permanganate, is dissolved in 500 milliliters of water. Means the volume of the solution is 500 milliliters. Question is, what is the molarity? You should attempt this before moving on. Alright, so to find the molarity, we need moles and we need liters. 50 milligrams can be converted to grams by multiplying by a conversion factor of 10 to the negative third grams over milligrams. That cancels milligrams and gives grams. We could then multiply by a conversion factor to convert from grams into moles. 158.034 grams of potassium permanganate in the denominator cancels grams. Leaves us units of moles. Solution in 0.00321 moles. 500 milliliters can be converted to 0.5 liters by multiplying by 10 to the negative third liters per milliliter. Once we have moles and liters, we divide the moles by the liters to obtain a 0.00642 molar, big M, or mole over liter, moles per liters, solution. So the molarity is 0.00642, and we can express that as 0.00642 molar, or 0.00642 big M, or 0.00642 mole per liter. Let's consider a 5 milliliter sample of the solution in the previous problem. How many moles are in this sample? Well, this is an algebraic rearrangement. If molarity is moles over liters, take molarity and multiply it by liters to equal moles. There's a 5 milliliter sample, so we can convert that to liters by multiplying by this conversion factor. Cancel milliliters, give us liters. 5 milliliters is 0.0050 liters. And we can take the molarity, 0.00642 moles per liter, multiply by the volume in liters. Liters cancel and give us the solution in moles, which is what we want to know. How many moles of solute, potassium permanganate, remember, is in the sample. Alright, you attempt this. How many grams of sodium chloride are in 11.5 milliliters of a 0.1 molar sodium chloride solution? Alright, you attempt it and then move on. Molarity is defined as moles over liters. If you want moles of something, you can take the molarity and multiply by liters. Alright, so convert 11.5 milliliters to liters. We're working molarity calculations. We will generally need volumes in units of liters. Multiplied the molarity, moles per liter, by the volume in liters to get the number of moles. This is moles of sodium chloride. That's our solute. So if you know moles, we can convert to grams by multiplying by the molar mass. 58.443 grams over 1 mole of sodium chloride. This gives us 0.0672 grams of sodium chloride. Or we could have done this entire calculation in one step. Molarity is multiplied by volume, which is then multiplied by conversion factor from moles to grams, 58.443 grams over 1 mole, and the solution is 0.0672 grams of sodium chloride. Alright, so you could do the problem in 2 steps or in 1. Alright, finish your notes on this before moving on. What volume of a 0.230 molar solution of magnesium chloride contains 10 grams of magnesium chloride? Alright, you attempt and then look at the solution further in the presentation. Molarity equals moles over liters implies, algebraic rearrangement, that liters equals moles over molarity. So, I present a calculation, 10 grams multiplied by 1 mole of magnesium chloride over 95.211 grams gives moles magnesium chloride here in the numerator. I divide that by the molarity in moles per liter, and that gives 0.457 liter. Alright, it's important to note that if liter is in the denominator of an expression, that it appears in the numerators. Meanwhile, note that grams have canceled in the numerator, leaving moles, and then moles in the numerator cancels moles in the denominator. Alright, now I've just changed the expression from liters, from the word liter to big L here, which appears here. Maybe this shows more clearly how units cancel. Right. We weren't asked for any particular volume units, so 0.457 liters is fine. If you were asked for milliliters, the answer would have been 457 milliliters. Alright, let's move on to another. What's the molarity of a solution prepared by dissolving 15 grams of sodium hydroxide in enough water to make a total of 225 milliliters of solution? In other words, water is added to the sodium hydroxide until the volume of the two mixed is 225 milliliters. You should attempt this before moving on. Here's the solution. 225 milliliters is first converted to liters. And then I calculate the molarity by converting grams to moles. 15 grams is multiplied by 1 mole over the molar mass of sodium hydroxide. The volume, 0.225 liters, appears in the denominator. And the solution is 1.96 moles per liters. Right. Again, notice in the numerator I have moles because I have take grams and multiply it by moles over grams. In the denominator I have liters. So the solution is 1.96 moles per liter. Alright, make notes of the solution before moving on. Attempt this one. How many grams of HC2H3O2 and 350 milliliters of a 1.4 molar solution? You should try this before moving on. Here's the solution. Convert 350 milliliters to liters. Here I show the calculation in two steps. I have a step where I multiply liters by molarity to find 0.49 mole. And then I take 0.49 mole and multiply it by the by a conversion factor. Molar mass of HC2H3O2 in the numerator, mole in the denominator. Solution is 37 grams. Alright, this concludes the first lecture for Unit 4.